In this video, we will talk about how to find the equation of a rational function from a graph. So let's say that we have this graph right here, and we want to find what is the rational function that describes this graph. The way that we can do that is we can write a function in the following form. F of x is equal to a, some constant, multiplied by some factors in the numerator, divided by some factors in the denominator. And the way that we actually find these values is we can use these three rules of thumb right here. So we use the vertical asymptote in the graph to find the factors of the denominator, so these factors. We use the x-intercepts of the graph to find the factors of the numerator, so these factors right here. And then we use the y-intercept to find the value of this constant a. So let's go ahead and work through this example. So if we have this graph here, the first step is let's try to identify the vertical asymptote. So if we're looking at this graph, it looks like there's a vertical asymptote right here along this line. So this is the vertical line that both of these blue lines are approaching, but they're never actually touching. So we can see that looks like it's at an x value of 1. So here's the origin. This would be an x value of 1. So here's what we can write. F of x, some function, is equal to a times some factors. We don't know the factors in the numerator yet, but the factors in the denominator will be wherever the vertical asymptote is. So at an x value of 1, that would mean that the factor in the denominator is x minus 1, so the opposite value. And we'll see that if we were to plug in an x value of 1 right here, we would get 1 minus 1, which is 0, which is why x is equal to 1 is one of the factors. So since we only have one vertical asymptote, that means we're done with the denominator. Next, we can move on to the x-intercepts. So let's use the x-intercepts to find the factors of the numerator. So if we're looking at our graph, we can see that it only crosses the x-axis one time right here. And that would be at an x value of 1, 2, so negative 2. So at x is negative 2, that's our x-intercept. So what we can say is that's the factor of the numerator. So the factor would be x plus 2, so the opposite of negative 2. And we'll see that if we were to plug in a negative 2 right here, we would get negative 2 plus 2, which is 0, which is why that's a factor in the numerator. The very last step is use the y-intercept to find the value of a. So let's identify our y-intercept. So that's where the graph crosses the y-axis. So we can see that it crosses right here at this point. So that would be at the point 0, 1, 2, 3, 4, negative 4. So at 0 and negative 4, that's our y-intercept. So what we can do is we can say when x is equal to 0, y must be negative 4. Or in other words, f of x must be equal to negative 4. So to solve for a, here's what we can do. We can say negative 4 is equal to, we're just going to plug in a 0 wherever we see an x in this equation up here. And we're going to solve for a. So we get a times 0 plus 2 is just 2. So we can actually just write 2a over, if we plug in a 0 right here, we get 0 minus 1, which is negative 1. So we get negative 4 is equal to 2 divided by negative 1 is just negative 2. So we have negative 2a. And to solve for a, we can divide both sides by negative 2, and we find that a is equal to negative 4 divided by negative 2 is a positive 2. So up here in our equation, instead of writing a, we can replace that with a 2. So we'll just write a 2 right here. And this is going to be our final answer. This is the rational function that this graph represents. So you can use this exact same process to find the rational function that any graph represents. Just use these three rules of thumb. And also keep in mind, you might come across a graph that has more than one vertical asymptote and more than one x-intercept, which means you would just have more than one factor in both the numerator and the denominator. So just keep that in mind.